So our next presenter is John Mailhot from Imagine Communications, and he's going to be talking about an actual application of ST2110 to sports production. This is an amalgam presentation, so it's not talking about a specific single vendor, but or a single sports venue, but it does represent real, actual case studies, and I think it's going to be very interesting. So take it away, John.
Sure. Thanks, Wes. Good to meet you all. So as Wes mentioned, we're talking about 2110 for sporting venues. Now, what's a sporting venue? Well, in professional sport in the US, and I'm sure it's the same way in Europe, an OB truck is hired by whoever bought the rights. So if you buy the rights to Premier League or if you buy the rights to an NFL game, you'll hire a truck and that truck's going to do your production. But the truck pulls up to a stadium and every one of the, I'm supposed to stand here so it's lined up properly. Every one of the stadiums in the National Football League or American football, sorry, or the National Basketball, National Hockey, every one of the stadiums has an inside production that drives the big scoreboard, the giant screens in the middle of the stadium. Sometimes it drives the signage, drives a production out to the suites. The people who buy those suites pay a lot of money for them. They don't want to watch commercials. So that inside production facility is part of the venue, and it's there all year round. Now, of course, it takes some of the feeds, the ISOs of the cameras, from the truck, and often there's venue-mounted cameras that are part of the venue, you know, the one that's right over the center of the court, the ones that are in certain positions around the basketball arena, that the truck, when it pulls up, knows it can get those from the in-house production. So they share cameras bilaterally between the truck and the venue and the truck. These stadiums get a certain usage pattern. So the National Football League in the US, these stadiums cost $1 billion each to build, and they have 8 home games. So the math is not so good. You say, well, what happens the rest of the year? The basketball and hockey, a little better. There's 41 home games in each of those seasons. I don't know why they're exactly the same. Very different sports. They are both the same. And so each of these venues hosts other events through the year. They'll typically, if they have one night out of 7 that's dark, that's a lot. So they try to have about 250 events per year in these venues. Concerts, farm shows, agriculture equipment, you name it. If you go to a big venue like Madison Square Garden, it's got an event every single day, sometimes 2. So they're really very focused on keeping the venue full. But every one of those events has a different set of requirements, and most of them involve this inside production facility. Now, universities, the big universities in the US, they also have football teams with television rights. And so in the universities, the football team will drive the existence of a big stadium. That stadium has an inside production facility. But then that facility is used to produce every other sport on the campus. Field hockey, soccer, what we call football, of course, lacrosse, track, gymnastics, you name it, they're all produced in that same inside facility. So it's actually a very large facility. And in the universities, the problem is that that facility is really spread out over a whole campus. They have cameras and production elements in every different field, every different gymnasium all over the campus. And so it's a tremendously large distributed facility. In the NFL and the NBA, the facility is really one place, but it's huge. If you look at pictures of these sporting venues, they're gigantic facilities. So what makes the projects interesting? Well, the stadiums are really, really big. 500 meters does not get you far in a building that size. So suddenly you're into single mode fiber, not in, even if you were doing SDI, you'd be on single mode fiber in these buildings. Sometimes the refit is into an existing facility. If you take a facility like the Los Angeles Coliseum, it was the host of the 1932 Olympics and the host of the 1980 Olympics if we'd had them. 84, 80, whichever year that was. And it's still standing. the team finally moved out when they moved to Las Vegas a few years ago. So these facilities will get refreshed every 7 to 10 years. They'll do a complete technology refresh, but the concrete and the walls are all still there. So that's a challenge in some of these projects that you have to fit into a facility that maybe already exists. The flexibility, like we talked about, if every production having different requirements, is a challenge. It's not like an OB truck where you build it and then the same crew takes it from event to event. Now it's different operators and different people coming in. In the universities, often the operators are students. And so their technical knowledge is both good and slim. And then, of course, every event that has a rights holder, a truck pulls up with a different expectation of what you're going to hand them and a different opinion of what they're going to hand you. So every event has a certain amount of flexibility required. So those are the challenges. Now, why does 2110 help? Well, 2110, because it's IP-based, it gives you some leverage to attack these problems of scale. So the infrastructure is inherently fiber. Nobody pretends to do 100 gigabit or 25 gigabit over twisted pairs anymore. The idea of, oh, I'm going to take a 8-wire connector and make my little RJ45, no, that's all over. It's fiber, 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 fiber. And for short runs, direct attach cables. So the nice thing with IP-based systems is that you can use the leverage of the IT technology to get just the right fiber and just the right SFPs for the application. So for things inside the room, you can use direct attach cables. For short runs within the sort of near area, you can use OM4. And then for longer runs, maybe you have to go to the cameras on the other side of the stadium or the cameras in the ceiling. For those, you're going to use single mode and the appropriate SFPs. And then in the college campuses, often there could be 10 or 20 kilometers between the buildings sometimes. So again, you can use single mode fiber and get there with very minimum trouble. But equally, the infrastructure wants to be redundant. When you start having that much fiber and that many connections, especially in a campus environment where you've got lots of ways the signal could get there, building out with 2022.7, so you have the redundancy of switches, the redundancy of fibers, the redundancy of SFPs, you then have protection against loss for every packet. You have protection against loss for every SFP, for every fiber. So it's a tremendous ability to have a resilient network, even in a very challenging physical environment. Now, one thing you'll see, I'll show some pictures of these projects, it just takes up a lot less space and has fewer cables. And you might say, who cares about cables? But if you say that, you're not a system integrator. Because if you ask a system integrator what the cost of the project is driven by, it's driven by how many cables there are. Because every cable has to be made, every cable has a label, every cable is installed by somebody, every cable is potentially a problem. So just the simple act of reducing the number of cables substantially does save money on projects, and it saves overall cost on the system. Now, the other thing is going to IP means you never have to apologize or worry about the system needing to be bigger. So most of these sporting venue refreshes that are happening right now, there's a concern that it will have to do UHD. Maybe it doesn't have to do UHD on the first day, maybe it does, but there's a concern that during the life of the technical infrastructure, the league or one of the clients may demand that it do UHD, so they have to have a path and a strategy to implement UHD, even if it's not a day one requirement. So when you go to an IP infrastructure, especially with 100 gigabit infrastructure, that's okay. UHD, the bandwidth is there. You may not have purchased all the ports you would need, but you can always upgrade. You can always make it bigger in IP. The core switches for these projects, we're using the smallest models of switches that go to extremely large sizes. So here's a nice example. So this is one of the basketball arenas in the US that we did last year. This one's in Milwaukee, in case you follow American basketball. And so you can see this is a pair of Arista 7504s. They've only got 2 of the 4 slots even used. They're ready for more. Again, they had a ready-to-do UHD requirement, so that's why they went with the larger frames, but the cards are not populated because they didn't have a UHD today requirement. This system could scale, that system could scale to 4000 by 4000 3 gig signals or 1152 by 1152 UHD, it's running at about a third of that size right now. So they used active optical interconnects, AOCs, for inside the room. They used multi-mode for getting to nearby suites, and they used single mode for the longer runs in the venue. So this fiber to the core, imagine 2,000 by 1,000 SDI routers. Those would be 4 racks of equipment. This is a half a rack, and that's only because there's some space between them. So it saves a lot of space. And space and cable is money, right? It's very straightforward. Now, I like this picture better. So this is the CCUs and the multi-viewers. So what do you notice about the CCUs? What are all those SDI connectors on the back? Well, they're left over, but all this stuff that you used to have to wire up, every single one of those, suddenly it's a fiber, a pair of fibers, main and protect. But imagine the labor savings by not having to make every one of those cables. It's huge, right? So yes, the IP equipment itself costs a little bit more, but if you look at the overall project cost, you've saved a lot of money by not having to design, draw, project manage, and fit out all those cables. The days on site, how many days does the crew have to be there to install it, was reduced significantly just by having fewer cables. The same thing on the multi-viewer array. It looks like a lot of cables, but each of those 2 RU boxes is a 48 input, 4 output multi-viewer. If that was SDI, you couldn't make them that small. They would be these big honking things, and they would take a ton of cables. So there's an 8-to-1 cable reduction just by going to IP. That's really significant in the economics of the project. So how about the audio side, right? Well, in audio, there's this challenge with SDI with embedded audio, and the challenge is that first, you're limited to 16 channels. Not always a problem, but sometimes a problem. And the second is that every time you touch it, you have to disembed the audio, re-embed the audio. It's just a lot of extra stuff. So in 2110, the audio is always separate, and it's beautiful in production because the audio is separate, so you pick the audio you want. You don't pick the audio you don't want. It's all straightforward. And that is a huge savings because now you can buy an audio console from your favorite vendor, Studer, StageTech, Calrec, whoever your favorite is. They all speak AES-67, all the real ones. They all speak SMPTE 211030, which is basically AES-67. So now the audio console drags up, hooks up to the network, and it pulls in the signals it wants quite directly. No more embedders and disembedders and re-embedders, no more creating MADI to go over there. It's a tremendous savings of effort in the integration to not have to be dealing with every audio signal as its own little differential twisted pair. Remember that these facilities do 250 events a year, and every one of them has different audio requirements. I mean, they all kind of say, well, yeah, get the cameras to the switcher and I'll sort it out. That's the video setup. The audio setup takes hours. And so the fact that now we've simplified it so every signal's available and the A2 just sits down and goes through the list and says, yeah, I need that microphone, I need that playback server, tick, 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 assigns them to faders, they're ready to do their show. It takes hours off of their job because we've simplified the project. And then, of course, the dirty secret is the control system has to tie it all together. But that's always been true. It's no change. It's better because the control systems now are better with the IP. They can do more. They can usually deal with more devices. Now, there's a similar benefit in timing. If you've built a facility, you've realized, yeah, to build a facility in SDI, you have to build a blackburst distribution chain. You have to have ACOs at the front end of it to switch over between your main and protect generators. If your generator fails, you've got a big problem in an SDI plant and an IP plant. So you better have a backup generator. You better have switchover between it. And then you have to distribute black. And you have to distribute time code to things that need time code, which is a surprising lot of things. You have to distribute DARs to the audio guys and word clock to some of them. Oh, and tri-level to some of the HD equipment that doesn't like blackburst. So all this is a pain in the neck. Each piece of it's a pain in the neck, and together it's a big pain in the neck. PTP replaces all of it, right? PTP uses the wires you already ran for the video. and it gets time to everything that needs it. And it's format flexible. PTP doesn't care if you're doing 3 gig or UHD or SD or audio. PTP is PTP. It's universal. It doesn't care what format you're operating in. But also, on the production side, by having PTP timestamps on every packet, it provides a technical mechanism to sync up the audio and video. Because remember, in these stadiums and these venues, there's microphones all over the building. There's cameras all over the building. When you timestamp it properly, you can really mix any microphone, any camera. They all meet at the switcher, they all meet at the audio mixer, and you're producing your show. Otherwise, if it's all coming through embedders and frame syncs and disembedders, now you're sitting there as the A2 trying to trim out the delays that the technical infrastructure put in without any help. So these timestamps are what help the system make the audio line up without you having to adjust it. You still can adjust it by hand for artistic effect or for maybe overcoming real delays, but at least the technical infrastructure nets out its own introduced delays. Now, the biggest advantage in these projects actually comes from having choices. Now you say, well, what do you mean having choices? Well, you know, you'll walk around the floor, this is a huge show. How many camera vendors are there? There's a dozen, right? How many big ones? You know, Sony, Grass, Ikegami, you know, there's big vendors out there. Most of them have a 2110 option on their camera now. Similarly with switchers, you know, again, Sony, Grass, Ross, you name it, there's a lot of switchers out there. Most of them have 2110 options now. So 2110 is providing a level playing field that you can build the project you want using the equipment you want. In addition, 2110 is providing an even playing field for integrators. So I'm going to show you pictures from a couple of projects, and what you'll see is, what the picture doesn't tell you, rather, is that one of the projects was integrated by Diversified, another was integrated by Beck, and another one was integrated by CTG. And these are 3 different SIs in the US that, you know, that's what they do. But the point is, they weren't, you know, one magic integrator that understands all the details. It's 2110 is providing a mechanism for every piece of the puzzle, the vendors, the integrators, and ultimately the customers, to choose equipment and choose partners and build working systems. So, for example, one of the basketball arenas was a Grass cameras and a Ross switcher. It's their choice. I'm not sure, whatever. So everybody picks, and they had the EVS XT4K replay, Imagine multi-viewers. I mean, if it didn't have some Imagine piece, it wouldn't be on my slides. But you know, those were the choices made by the creative team of that customer. Now here's a football arena, and American football, sorry. And so in this case, they were a Grass camera, Grass switcher house, but with the Evertz replay. And then they liked the Tech generator, the Tech Prism. I would say we use a Tech Prism in every project. You got to have some piece of test equipment, just like an SDI, but even more important, an IP. And then again, it was the Imagine controller and multi-viewers. But the point is that 2110 provides this level playing field that you can choose the camera you want, the switcher you want, the replay you want, the multi-viewer you want, and then the 2110 allows it to all work together. And this is in practice. All of these facilities I'm showing you are making money for their owners today. They're not theory projects. These aren't, you know, like bids for some other season. This football stadium is running. It's making game, you know, their first game was a month ago. So it's up, right? And then the same thing, the second basketball arena is, again, this one was Sony cameras and a Ross switcher. Again, the Evertz replay and the Tech generators and Imagine multi-viewers. So again, 2110 provides that level playing field that you can mix the parts you want, pick the integrator that does the job you want, and put it together and get a good system. So all in all, with 2110, it's again, the scalability to go as big as you want. You know, there's no artificial cliff at a 1K by 1K. With IP, you can make a really, really big system if you need to. And some of these systems are bigger than you'd expect. You know, if you look at some of the sporting venues that are coming up, they're bigger than a big TV station by a lot. It gives you this economy of physical space and economy of cabling. You know, an 8-to-1 reduction in cabling or a 16-to-1 reduction if you count both ways. That's a lot. And it's very meaningful in overall project cost. The audio flexibility, that suddenly the audio console is just hooked to the network and all the signals are available. It's a big deal if you're setting up the audio that you don't have to worry about picking which disembedder and which channel and all that. It's quite nice. And of course, that the timing is just built in. You don't have to build a whole separate timing infrastructure is quite helpful. And ultimately, that system flexibility that when you're designing, you can pick your partners, pick your integrator, pick your camera, pick your displays, pick everything, and go. So, are there any questions about this or any other topic? I'll take topics on anything.
So do we John, thank you very much. That was great. Do we have any questions? We got a minute or two. Well, one question I had, John. You talk about mix and match. Does that apply to control as well?
It does and it doesn't. So within, say, devices that implement AMWA NMOS, that's great because that provides a controllability that we don't need to write a driver. Each of these projects tended to have at least one new device that we had to write a driver for, but that's been television for years, right?
Oh, of course.
So
yeah.
we're not afraid of writing drivers, but we sure would rather work on other stuff. So that's where NMOS comes in. So the control system is happy to do NMOS. We have seen devices that have NMOS in practice. And what you'll see in the JT&M test results is there's a lot of devices that tested successfully for NMOS. And so we expect those are accompanied by product announcements here at the show.
Any other questions? Yeah, hold on just a second.
Hi, Chris from Atos BNCS. Just a question about, in the examples you were showing of those real working systems, 2110 systems, the primary devices that were shown in the examples were video devices, some video with audio. The complexity increase in terms of 2110 handling audio alongside video compared to 2022-6 embedded. What's been the experience on that, and how mature is that in terms of interoperability?
So the challenge in 2110, to some extent, is that people have different ideas of how many, say, audio streams, audio channels to put in a stream. And so each facility had to make a choice of kind of how they were going to operate. What tended to happen in each of these venues is that the audio console, one of them was CalRoute, one of them was Stage Tech, I'm not actually sure which the third one was. The audio console, they would tend to route all of the streams to the console and let the audio operator sort out what they want. It's a little different than television, but it's kind of works for them because their whole thing is they'll have a giant audio console anyway, and so they just let the audio matrix in the console sort out the picking and choosing. And then we made that another level in the routing system. So if they were routing this to that, it would actually work through the audio console to do the final tweak. And that way that it kind of worked out the channels problem because we let the matrix in the audio console manage the final mono level.
Okay. Thanks a lot, John. Everybody, round of applause.
Yep.
Appreciate it.
No problem.